and welcome to today's class. For today, we are still on trigonometric function of differentiation. So, discussing on trigonometric function of differentiation. But today, we are going to be discussing about how to solve complex problem when it comes to trigonometric function, right? The higher parts. We're discussing about higher parts of trigonometric functions, right? So, let's take an example and let's start. But for you to understand more concepts or more better understanding about trigonometric function, I will drop a link on our first class on trigonometric function on the description of this video. So watch the description, check the description of this video, and watch our first class on this man here. For today, let's examples, right, involving higher parts. Let's say I have y to be equal to tan cube into exponential 2x per se. Let's say I have y is equal to tan cube exponential 2x. Of course, in our previous class, we said tan cube means tan of exponential 2x in 3 places. Alright? So, of course, how you solve this man? Your first task, first is first, we know that we call the thing in bracket u. So let u to be equal to exponential 2x. If I differentiate u with respect to x, I'll have what? The u over the x to be equal in value to, for exponential function shortcut, we said differentiate the part. If I differentiate 2x, I'll have to repeat the question, exponential 2x. That's the shortcut to this man here. Of course, y is now equal to tan cube u. Listen, we said this man should be u. Of course, I'm simplifying, I have the u at the x with this. And I said y is now equal to tan cube. You said this is u, this is u here. Of course, tan cube u, I need to simplify it, right? So simplify this man here. I will say tan cube means tan cube u means tan u times tan u times tan u in 3 places. Now let v be one of it. So let v to be one of it, tan u, right? I said tan cube u. If I have tan cube u, it simply means tan u all cube. It means this man here in 3 places. Now let v be one of it. Of course, if I differentiate v with respect to u, I'll have the v over the u, which is equal to, if I differentiate tan u, I'll have the sec squared u. Of course, at this point here, from here now, y is equal to tan cube u. Listen, but we just said tan u alone to be v. That becomes v, then I have my cube here. Of course, at this point, the reason y with respect to v becomes the y over the v equal to what the general method, that becomes 3v squared. At this point, apply chain rule, function of a function or function of several functions. At this concept here, that becomes using chain rule. I'll have that the y over the u, the y over the x is equal to, what is first, the y over the v. I'll have the y over the v multiplying what the v over the u, the v over the u multiplying the u over the x, right? Of course, put in value, I'll have that the y over the x is obviously equal in value to the y over the u. Check, the y over the u is 3v squared. I have 3v squared multiply the v over the u. The v over the u is what? Sec squared u. I'll have sec squared u. Finally, the v over the x is obviously what? 2 exponential 2x. Of course, v, but v was what? Check, what's v? But v was what? Tan u. So v was tan u. Put in v here, I'll have that the y over the x is equal to 3 into, this is tan u, right? All squared multiply sec squared u multiply u exponential 2x. Of course, 3 times 2, listen, 3 times 2 becomes 6. I'll have 6, right? Next up, I'll pick 3 and 2, right? I can take tan, next up, tan u all squared, right? Next up, let me pick sec squared u, and finally, exponential 2x. At this point, the y over the x is obviously equal in value to. Now listen, at this point, I'm seeing u. Take u back to x. Of course, what's u? U was exponential 3x. So at this point, we say, but u was what there? Exponential 2x. Of course, I'll have that the y over the x is equal to 6 into tan squared. I can say tan u squared to be tan squared u. Of course, tan squared, what is u? Exponential 2x, right? All into the sec squared u. What was u? Exponential 2x. Then what the finally what? Exponential 2x. Of course, I can even bring out this man here to the front here. Becomes 6 exponential 2x all into tan exponential 2x. Then what the sec squared exponential 2x as my final answer after differentiating this man, right? So let's another example on trigonometric function of higher powers. Let's say I have y to be equal in value to let's say cos to power 4 into exponential 3x minus 2. For instance, let's say we are told to simplify this man. Let me just add x to it, right? So we add x to it, this man. So we are told to differentiate this man. What's our first task? We said your first task is to put the thing in brackets, call it u. Of course, let u equal to what? Exponential 3x minus 2x. Differentiating u equal to x, I'll have the u over the x is equal to, differentiate this man here first, I'll have 3 exponential 3x. I believe you should know how I got to this. Next up, negative, you need 2x, I'll have what? 2. That's all. Next up, we said y is equal to cos to power 4 u. This was u. Hence, I have this back here. But cos to power 4 u means cos u to power 4 in 4 places. Hence, let v be one of it, as we said initially here. So let v to be what? Cos u. Of course, if written u, v, relative to u, I will have the v over the u is equal to, if I differentiate, listen, from our concept, if I differentiate sine x, I will have if I differentiate cos x, I will have negative sine x. Similarly, if I differentiate cos u, I will have negative sine u. Alright, at this point, y is now equal to cos u, we said it's v, that becomes v to power to power 4. Of course, this is the general method here. I'm writing y without the v becomes the y over the v is equal to 4v to power 3. At this point, using chain rule, of course, I have that the y over the x is equal in value to, what do we say first? Pick out this one first, right? Sorry, this one here, that becomes the y over the v multiply the v over the u multiply the u over the x, right? Put in value here. Alright, from here, put in value, I'll have that the y over the x is equal to, check, what's the y over the v? Of course, y over the v is what? 4v cubed. I have 4v cubed, alright, 4v cubed, multiplying the v over the u. V over the u is what? Minus sine u, negative sine u. Finally, I have the u over x. v over the x is 3 exponential 3x, 3 exponential 3x, then what then? Negative 2. I have this. Of course, we said v. Even I can even say it, take it this way, in this manner. This is in bracket, please. In bracket. Alright, I can take it this way. I can see negative 4. I can bring out negative 4. First is first, then v cubed, next up, sine u into 3 exponential 3x minus 2. And correct. Right? Divided by the x. Alright, at this point, I'll have that divided by the x is equal in value to, I have but, sorry, before this, but v was what? What was v? Check, what's v? V was what? Cos u. I have cos u. Cos u. Of course, divided by the x is what? Negative 4 into cos u all cube. That becomes cos cube u. I'm done with this. Next up, sin u. Finally, 3 exponential 3x negative 2. Of course, take u back to x, but u was equal to what? What of u? U was exponential 3x, exponential 3x negative 2x. Finally, divided by the x will be equal in value to negative 4 cos cube. What was u? Exponential coming cos exponential 3x minus 2x. I'm done with this. Next up, sine. What was u? Exponential 3x negative 2x. And finally, that's for this man coming. This is for this first man here. For this one too, I have this. Finally, bring this one down. That's 3 exponential 3x minus 2 as my final answer after solving this one. So this is how to solve problem via trigonometry functions with higher powers, right? Now next class, let's move to the trigonometry inverse of differentiation, right? Sine inverse, cos inverse, and tan inverse. All right.